Welcome to the Async Coding Interview series by Paul Fruitful. In this season, we'll be focusing on data structures. Grab your popcorn and stay tuned. Good day everyone, welcome to another episode on the Async Coding Interview. So in this episode, we'll be looking at the implementation of the doubly circular linked list. And if this is your first episode in this series, I advise you to go back and watch the previous videos so that you can get a hang of what this series is talking about and you can understand data structures better. Okay, so before I dive deeper into the implementation of the doubly circular linked list, I'll just like to repeat the definition. If you watched the first video, that means the introduction to the linked list data structure, I defined all the types of and all the variants of a linked list, but I'm repeating this definition so it can sink in. And if this is your first time of watching this series and this is your first episode in this series, I advise you to start from the beginning so that you can understand everything I say here better. So let's dive into what the definition of a doubly circular linked list. A doubly circular linked list is a linked list with each of its individual node having two pointers, one to its next node and the other to its previous. It is just like the doubly linked list, but the first node has a next pointer to the last node and the last node has a previous pointer to the first node, vice versa. And like the previous episode was talking about the implementation of the circular and the circular linked list, or you can also call it the singly circular linked list. So you could you saw that it was like it's like a variant of the singly linked list, just like the normal linked list, but the difference is that it repeats in a cycle format. So next up I'll be using a visual depiction to explain the doubly circular linked list, because it looks confusing at first, but if you just know it that it is a variant of the doubly linked list, it's just that there's no null value in it or no null node in it, you'll be able to understand it better. Okay, as you can see, this is the visual depiction of the doubly circular linked list. So I always use this visual depiction to show you what you are working with. So as you can see, this is the head. So the first node and the last node, 1 is the first node, 5 is the last node. So you can see that each of the nodes have two pointers, one going to the right and one going to the left. So the one going to the left is the next pointer, the one going to the right is the previous. And as you can see, the last node has those 2 pointers. So you can see the one that is going to the left, like it takes a turn from the right and goes to the left. That's what makes it a cycle. So 5 has a previous pointer to the first node, which is 1, and 1 has a next pointer to the last node, which is 5. So it's as that simple. Okay, so right now we'll be moving from the theoretical aspect of the doubly circular linked list to the more technical aspect. It may get a little bit complicated at first, but if you take your time to watch, and you may have to watch in a lower speed, so you can easily digest and understand everything I'm going to be doing in the next few clips. Like in every other implementation before this, we always start with the node class and the node object instantiation. So that's why we have to create a node class. So in this node class, we'll be using four attributes: the value attribute, which has the value of the node passed into the linked list; the next attribute, which has the next pointer to the next node; the index attribute, which has the index address, like it's like an address for the node; then the previous attribute, which has the previous pointer to the previous node. So it's that simple. So next we'll be going through normal procedures of how to implement the doubly circular linked list. And note, this is just a pseudocode, so you can implement it in your preferred language. So this is a doubly linked list class, and this is the actual linked list. This is what houses all the nodes that are going to be in the linked list class. So at its instantiation, it instantiates with two attributes: the head attribute, which contains every node that is going to be added into the linked list, and the length attribute, which which can be used to tell how big the linked list is, or it can be used to tell the number of nodes that is in the doubly circular linked list. So next we'll be looking at other methods that makes this doubly circular linked class functional. Okay, so this is the insert method of the doubly circular linked list. So what this method does is that it inserts nodes into the linked list. So first we create an instantiation of the node class, and we assign it to the node variable. So we fill in that node object with its attributes. So the value attribute is going to have the value argument of the insert class. The next attribute is going to have the node which is at the head. Yes, the current node at the head of the linked list. And then, and remember, at every instantiation, if this was the first node to be added, that means the next of this node object is going to, the next attribute of this node object is going to be null. Then the previous is also going to be the previous attribute is going to be assigned null because there is no node in front of it as for now, and then the index is going to be the current length. So we created a conditional to check if the head is not null. We assign the current node at the heads these previous attributes to the node which is to be added. So if the head is not null, this previous which was null at that moment is going to be instantiated, is going to be assigned to the node which was the node object which was just instantiated above. So then we update the current node at the head to this node that was just added into, that was just instantiated in the insert method, and then we get the first node. Now this is where it gets tricky and different from the other implementations, the singly linked list and the doubly linked list. We get the first node that we assigned the first node next pointer, which was pointing to null. We assign it to the node that was just added into the linked list, the node that was just put in the current head. So we assign the next pointer to that node, and then we get the node at the currently at the head, and we assign its previous attribute, which would be normally null. We assign it to the first node. Yes, the first node that was added into the class. Then that's where we create the cycle. Then we increase the length by 1. So that's just it for the insert method of the doubly circular linked list. So this is the get node method. So what this method actually does is that it takes in an index, that the node, an index argument, and searches for the node with a matching index attribute. And when it finds that index, it returns that node that has a matching index. So this is a pseudocode of how it works. So first we create a copy of the linked list. That means we create a copy of the head, and we are like copying the list collection. Then we use the while loop to traverse the linked list while every node's copy index is not equal to 0, because in circular linked list there is no null value, so you can't break it using that while copy is not null. So we keep on traversing the loop as long as the index is not equal to 0, and then if we find the node with a matching index, we return that node, else we move to the next one, and we keep going, moving to the next one till we get to the end of the list, which is the node with the 0 index attributes. And then if we didn't find any node with a matching index before that, we return false. It's as that simple. Okay, so this is the check if exists method, and this method is just very similar to the get node, but unlike the get node, it doesn't return a node object. What it does is it returns either a boolean value, either true or false. True indicating that a matching value was found inside the linked list. False, simply implying that the value like that doesn't exist in the linked list. So what it does is that it takes in a value argument, it creates a copy of the list, and it keeps on traversing the list as long as the current node index is not 0. And if it finds a if uses an if conditional to check if there's a node with a matching value, and if any node matches that condition, it returns true. Else we move to the next node by setting the current copy to the next node. And then if we couldn't find any matching value till the node was traversed to the end of the node, we return false. So it's as that simple. Okay, so this is the remove method, and what this method actually does, as its name suggests, is that it removes a particular node using the node's index. So we'll be running through how the method works. So first, we need to create a helper method inside the node function. The helper method is named delete. So you'll be seeing why we need to create the helper method soon. So first, we call the get node method. We call the get node method and take in that remove index argument and put it inside the get node index argument. Then we get the previous node of the node you want to remove, and then we call the delete method. The delete method is that helper method declared inside the node class. So what the delete method does is that it sets. Remember now, what the delete method works on the previous node of the node you want to remove. So if the previous node the delete method now gets that previous node and sets its next, which is the node you want to remove, to its next, and then it now sets its current next, which is the node we want to remove next, and we set the current next dot prev to the node, that's the previous of the node you wanted to remove, and then the operation is done. It's just as simple as that. And it may get quite confusing, but I promise you get a better understanding of it if you watch the previous episodes on the remove method of other linked lists. You will have a better picture of how this remove method works. Okay, so this is the remove method, and what this method actually does, as its name suggests, is that it removes a particular node using the node's index. So we'll be running through how the method works. So first, we need to create a helper method inside the node function. The helper method is named delete. So you'll be seeing why we need to create the helper method soon. So first, we call the get node method. We call the get node method and take in that remove index argument and put it inside the get node index argument. Then we get the previous node of the node you want to remove, and then we call the delete method. The delete method is that helper method declared inside the node class. So what the delete method does is that it sets. Remember now, what the delete method works on the previous node of the node you want to remove. So the previous node the delete method now gets that previous node and sets its next, which is the node you want to remove, to its next, and then it now sets its current next, which is the node we want to remove next, and we set the current next dot prev to the node, that's the previous of the node we wanted to remove, and then the operation is done. It's just as simple as that. And it may get quite confusing, but I promise you get a better understanding of it if you watch the previous episodes on the remove method of other linked lists. You will have a better picture of how this remove method works. So this is the print method, and what this method does is that it prints all the nodes in the linked list. So it's what makes the linked list, let's say, visible. So how it does that is that it creates the same mode of traversal as the get node method and as the remove, I say remove, and as the check if exist method. So this is what it does. It creates a copy of the list, and then it keeps on traversing as long as the current node index is not equal to 0, as it traverses, as it gets to each node, it creates their value and moves to the next one. And it repeats this process till it gets to the node with the index of 0, then it abruptly stops. So okay, so this is it for the um, linked list data structure. So we have been treating the linked list data structure for the past 4 episodes, and this is it for this episode too. And I'll be leaving the links to the Python implementation of this doubly circular linked list. So in the next episode, we'll be looking at another entirely different data structure, though it's still going to be linear. So stay tuned till then, and also check the links in my description. Thank you. Thank you for watching the video. I'll be leaving links to helpful resources to get you grounded in these concepts. I will be releasing a video every Friday, so click the subscribe button and stay tuned. Peace.